All right, so let's look at this example here where we're dealing with sodium chloride, so table salt, that is composed of one sodium ion, Na+, and one chlorine ion, Cl-. All right, so if we're dealing with a sodium ion, right, that's going to be sodium, which we know has 11 protons, and since it's a cation, it's positively charged, that means there's one less electron, so it has 10 electrons. The chlorine ion is composed of 17 protons and then therefore 18 electrons. All right. So the mass of each sodium atom is 3.8 times 10 to the negative 26 kilograms, and the mass of each chlorine atom is 5.81 times 10 to the negative 26 kilograms. Sorry that they have different sig figs, that's my fault. Let's assume that the sodium is 3.80. Anyway, so for a paper packet of salt containing 1 gram of sodium chloride, let's compute the following. So we'll compute the number of electrons and protons in that packet of salt, and then we'll compute the number of coulombs of negative and positive charge, and then also the net charge accordingly. Okay, so jotting down what I know here, if we're dealing with our sodium, all right, that is going to be 11 protons, so I'll use the symbol of P+ for proton, and 10 electrons. I'll use E with the minus for electron. And then chlorine is 17 protons and 18 electrons. All right, so kind of in total, if we're dealing with one molecule of sodium chloride, we're dealing with, let's see, 11 plus 17 protons gives us a total of 28 protons, and we're dealing with then also 28 electrons by doing that quick math. All right. So then one molecule of sodium chloride is overall electrically neutral. So we're also told the mass, so dealing with the mass of sodium, all right, that's going to be 3.80 times 10 to the negative 26 kilograms. And then we're told the mass of chlorine is 5.81 times 10 to the negative 26 kilograms. My pen's writing way bigger than I want it to, but whatever. So together, then that means one molecule of sodium chloride is going to have a total mass. So I'll just write that as M total. Let's see, adding these two numbers together, we get 9.91 times 10 to the negative 26 kilograms. All right, so you can use your calculator to verify that. Okay, so first, we want to find the number of electrons and protons going on in that 1 gram of sodium chloride. All right, so 1 gram of this salt, well, it would be useful for us then to determine how many molecules of salt we have in there. So if we're dealing with 1 gram of sodium chloride and we know the total mass involved there, we can do a quick conversion. All right, so since we're dealing with a mass of 1 gram, well, 1 gram is what, 1 times 10 to the negative 3 kilograms? All right, let's jot this down. So 1 gram is 1 times 10 to the negative 3 kilogram. All right. Well, we know that one molecule is 9.91 times 10 to the negative 26 kilograms. All right, so doing a little bit of quick math here, right, we can say that the number of molecules is then going to then be equal to our total mass divided by the mass of one atom. That's bad notation, right? Because I just called M total the other value. So let's go back. Instead of M total over here, I'll write this as M1 for one molecule. So what I mean by total mass here, that's this value over here, meaning total, so what I mean by now, total mass, that's the 1 gram of salt. And M1 is the mass of one molecule. Sorry if that was confusing. I don't want to restart my recording here. All right, so going through this here, doing this math, we're dealing with 1 times 10 to the negative 3 kilograms divided by 9.91 times 10 to the negative 6 kilograms. So looking at that, then we get about 1.009. I'll go to 4 sig figs just for rounding error, times 10 to the 22 molecules. Alright, so we just found the number of molecules in 1 gram of salt. Alright, which, thinking about Avogadro's number being on the order of 10 to the 23, this seems like a reasonable number. Right? I don't know if we're dealing with 1 mole or close to 1 mole here, but whatever, it seems somewhat reasonable. Okay, so let's see, we want to find the number of electrons and protons. Alright, well, this is the number of molecules we have. Then we've got 28 protons per 1 molecule, so we just take this number and multiply by 28, and that gives us the number of protons. So we take 28 times 1.009 times 10 to the 22. That gives us 2.83 times 10 to the 23 protons. And since we have the same number of electrons, then we'll also end up with 2.83 times 10 to the 23 electrons. All right. So part A, done. Part B, the number of coulombs of negative charge and positive charge. All right, well, we know that when we're dealing with the elementary charge, so the magnitude of charge of an electron or a proton, that is 1.6 times 10 to the negative 19 coulomb. So if we take this number and multiply by the number of proton or electron that we have, that'll give us our value for the amount of charge we have. So for our protons, amount of positive charge we have, we end up with, let's see, 4.52 times 10 to the 4 coulombs. All right. So that, for the amount of protons that we have a positive 4.52 times 10 to the 4 coulombs. And then for our electrons, we have a negative 4.52 times 10 to the positive 4 coulombs. All right. So therefore, if we're dealing with the net charge, our net charge then is going to be 0. Since we're taking a positive 4.52 and a negative 4.52 times 10 to the 4 coulombs, adding them together, giving us a value of 0, which is what to be expected, because we know how we have equal number of protons and electrons, so it should be 0. All right. So hopefully that was helpful in terms of dealing with protons and electrons and charges in dealing with that. And I think it's pretty cool that we actually computed this for like a very typical situation, right? 1 gram of salt, right? And it has this many protons, this many electrons, and this amount of charge. I think it's pretty neat. All right, have a good one.